had the historical way of working where we had lots of people, the users, working out of kind of office locations, whether that be kind of HQ or in branch sites. We started to see a kind of slow increase in remote working and more consumption of kind of cloud apps. Obviously that was very much expedited by COVID, and a lot of organizations had to very quickly adapt to a very large number of remote workers consuming a vast amount of SaaS applications. Legacy architecture tended to look like a combination of MPLS connectivity or direct site-to-site connectivity, but normally back to a customer headquarters or data center site where they'd have a pair of high availability firewalls that would have a single centralized internet breakout point. So SASE architecture is more of a dynamic mechanism to move away from that legacy type of connectivity. We see a shift from that MPLS connectivity more towards direct internet access, which is normally a lot more affordable. And SASE architecture takes those kind of connection mechanisms and you overlay a software-defined WAN, essentially. So you take those connection mechanisms, those transport mediums, the different bearers, and you say, okay, well, I want to forward performance-specific applications down whichever transport medium is going to give the most optimum performance. That's the first half of SASE architecture with the SD-WAN piece. The second half is Secure Service Edge, or SSE. And that's about making sure that essentially users can connect to the applications that they need to do their job from any location. So that could be from working from home, it could be from Starbucks, it could be from absolutely anywhere. And it's ensuring that you can put a security overlay on that means that you're making sure that the users and devices that are connecting, you have full visibility of, and you can apply policy to them to make sure only trusted users and devices are connecting to your applications. Additional security overlay that can be delivered via SSE includes functions such as Secure Web Gateway, which is essentially a web proxy. We can have full CASB functionality, so we can deliver essentially a security overlay into the different applications that you might be using within your corporate environment. We can have a cloud-delivered firewall, as an example, layer 3 all the way up to layer 7. And we can also have functionality such as remote browser isolation, where we can take the risk essentially away from executing access to applications away from the end user device and facilitate that via a sandbox environment. So the business benefits of a SASE architecture are really twofold. From an on-premise perspective, we have the ability to take away the risk of degradation to applications based on poor connectivity. So moving towards the software-defined piece, we can ensure that the applications that are subject to the likes of latency, loss, jitter. If you're looking at, for example, as an example, voice and video, we can ensure that they're always utilizing the connectivity medium that's going to give the best end user experience, essentially. When it comes to the SSE piece and how your users are connecting remotely, as well as the security piece, we can also factor in that the responsibility for the resiliency and scalability is taken away from you as a customer, and that's then provisioned by the SSE service provider, essentially. So it's cloud delivered, it's their responsibility to manage that scalability. You know, going back to the COVID example, that very quick increase in remote users, a lot of customers had difficulty scaling that when they were in the on-premise environment. Moving towards SSE and having that delivered via the cloud, it's the cloud provider's responsibility to deliver that piece.